also fine. So welcome to my channel, and it's your channel DK Education. So what is our last topic? So that is on hydrogen spectrum. We will we we have studied in previous video that spectral lines of hydrogen. So now we will study about ionization energy or excitation energy or ionization potential or excitation potential. What is that? So first we have tried the topic that is so what is ionization energy? So minimum energy required to take a electron at infinite orbit from any orbit. So that is illustrated by the example. So that's in nucleus, that is the orbit, and we take here that infinite orbit is here. So that is infinite orbit we take here. That is any orbit that like its first orbit n1. So there is an electron revolve around that. If or when we take electron from that orbit to infinite, so that required energy or minimum energy is in this process is required. That energy is called ionization energy. So that is small definition that why that minimum energy required to take electron from any orbit to at infinite orbit, that is ionization energy. The formula is that equal to E infinite minus E n. So here n1 E n1 is any orbit in which electron revolve. So if we take electron from any orbit to at infinite, then the atom is ionized. Then we say that atom is ionized atom. So that is ionized energy, and we know that infinite E infinite is equal to 0. So E is equal to minus E n1. So the energy of electron in orbit in which it revolves, so the negative of that energy is called IE. So for hydrogen atom we take here for first orbit n is equal to 1, for n1, for n2, and for n3. We know that at n1 energy of electron is 13.6 minus 13.6, and for E we take here minus, and there is also minus in 13.6, so that is 13.6 electron volt. So that is the energy, ionization energy for hydrogen when electrons when electron revolve in first orbit. For second, minus 1.81 minus 3.4, so that is 3.4 electron volt. For n3 that is minus 1.81, that is 8.81 electron volt. So similarly we can find it for n4, n5, n6, and n7 as well, etc. So that is ionization energy. Now we study about excitation energy. So what is excitation energy? So so that is E into E. So that is minimum or that energy required to take a electron from any lower orbit to a higher orbit, that is excitation energy. So energy so minimum energy required to take electron from lower orbit to any higher orbit, that is excitation energy. Though, so the formula is E n2 minus E n1. So that is higher orbit and that is lower orbit. So now it for by example for hydrogen. First we have to take for N1 and N. Here N2 is 2 and N is 1. So that is first Hc. First excitation energy. When we take a electron from first orbit to second, that is lower. That is the lowest orbit in hydrogen. So E into 1. So what is N1? En2 is here minus 13.4 minus. N1 is minus 13.6 minus 13.6. So here is also minus percent. That is that is 10 to into 2 electron. So that is also in positive. That is N energy of first excitation energy of hydrogen. That is means when we take electron in hydrogen atom from first orbit to second orbit, then we have to require this energy 10 to the power 2 electron volt energy we have required. Now we will study about ionization potential. Now we study about ionization potential. So what is the ionization potential? Ionization potential. So here also we learn that the logo E or that symbol E. IP. That is EIP. So what is that ionization potential? So here we replace it. Here we compare by that ionization energy, where energy in this we take potential. So energy replaced by potential. Then the definition is same as it is. What is the definition of ionization energy? When we replace energy by potential, then that the definition for ionization potential. So potential is also minus n. So here we take that electron. So what is the if here E and 1 in electron volt? So that is same as it is. But when it is in coulomb, then we have to divide it by E. IP to convert it into En1. If it is in joule, so we have to take here electron, because we know that E is equal to 1.6. So when we divide, then it convert into in electron volt, because we know that E is equal to that. That is when it is in joule. It is in joule. We take it in. When we take it in, then it converts into electron volt. So that is ionization potential. So now we study about ionization. That is excitation potential. Replace it by excitation. So excitation. What is excitation potential? So it is denoted by EP. So minimum potential required to take an electron from any lower orbit to any higher orbit. That potential is ionization potential. So here we take the formula for it. EP. If it is in electron volt, then we have no change in that formula. But when it is in joule, then we have to change. to convert in electron volts. So that is our today's topic. So I have to end that topic. Thank you.